Welcome to Daily Papers, the podcast where we break down the latest research into fun, bite-sized conversations.
Today, we're looking at a world where AI doesn't just answer your questions, but actually does things for you on the internet. Imagine an AI that can book your holiday, find the best deal on a new laptop, or order your weekly groceries, all by itself.
These are often called WebAgents. They're powered by large language models, the same kind of AI behind tools like ChatGPT. But there's a big challenge. What happens when they make a mistake?
Right. If you're just asking a question, a small error isn't a big deal. But if an AI is booking a flight for you, clicking the wrong button once can mess up the entire process. A single mistake can send it down a rabbit hole it can't get out of.
Exactly. So researchers are constantly trying to make these agents more reliable. A common strategy to make an AI smarter is called test time scaling. Instead of asking the AI for one answer, you ask it for, say, 10 different answers.
It's like asking a group of friends for directions instead of just one person. If 9 of them tell you to turn left, you're probably going to turn left. This is often called majority voting.
And this works pretty well for simple one-off questions. But this paper asks, what happens when you apply that logic to a complex, multi-step task like booking that flight? At every single step, clicking a button, filling a form, scrolling the page, you ask for 10 opinions and take a vote.
I can already see a problem. Some of those steps must be incredibly obvious. Like, after you fill in your name, the next step is almost always to click the next button. Do you really need to hold a 10-vote election for that?
That's precisely the first issue the paper points out: wasted computation. For easy steps, generating 10 options when they're all going to be the same is a huge waste of time, energy, and money. It's inefficient.
Okay, so it's wasteful on easy steps. What about the hard steps, the really confusing ones?
That's the second problem. When a step is genuinely difficult, the 10 suggestions might be all over the place. 3 say click this, 3 say scroll down, 4 say type that. The agent is basically confused in 10 different ways, and a simple majority vote doesn't give you a clear winner.
So the simple voting method is wasteful on easy steps and not very helpful on hard ones. What's the alternative?
The next idea researchers tried was to bring in a supervisor, which the paper calls an arbiter. This is another AI, a smarter one. Instead of just counting votes, the arbiter looks at the 10 different suggestions, considers the context of the web page, and makes an expert judgment call on which action is best.
So it's less of a democracy and more of an expert review. The committee of 10 makes suggestions, and a wise manager makes the final decision. That sounds much better.
It is, on average, but the paper found a fascinating new problem. Sometimes the arbiter can overthink. Imagine a situation where 9 out of 10 suggestions agree on the obvious correct action. The arbiter, trying to be clever, might notice the one oddball suggestion and think, that's a clever, non-obvious move, and choose that one.
And completely derail the task. I know people like that. They'll ignore the 99% consensus to go with a contrarian idea that ends up being wrong.
Exactly. So the arbiter helps on truly difficult steps, but it can actually be harmful on easy steps where there's already a clear consensus. And this leads us to the core idea of this paper.
Which is what? How do you get the best of both worlds?
You get smart about when to call in the supervisor. This paper introduces a new method they call CATS, which stands for Confidence-Aware Test Time Scaling.
Confidence-aware. So it tries to figure out how confident the AI is before deciding what to do.
Precisely. It works like this. First, the agent generates its 10 possible next steps. Then, before doing anything else, it just checks how much they agree. Do 9 out of 10 votes point to the same action? If so, the model is very confident. There's no need to call in the expensive arbiter. Just take the majority vote and move on.
But if the votes are split, a few for this, a few for that, the model is uncertain or has low confidence.
Right. And only in those moments of genuine uncertainty does it call in the arbiter. The supervisor is only brought in to break ties and solve the truly contentious problems, which is what it's best at. It's not wasting time on the easy stuff, and it's not given the opportunity to overthink the obvious decisions.
That makes so much sense. It's like you don't need a management meeting to decide what brand of paper to order for the printer, but you absolutely want one when you're deciding on a major company strategy. You allocate your best resources to the hardest problems.
And the results were fantastic. The CATS method led to a higher success rate on web-based tasks by up to 9% in some cases. And here's the kicker. It did this while using significantly less compute. In one case, it was over 2 times more efficient than the naive scaling method.
So it's better and cheaper. That's the holy grail.
It really is. The big takeaway here is that when it comes to making AI agents better, simply throwing more brute force computation at every single step isn't the answer. The smart approach is to be dynamic. Let the agent sail through the easy parts, but give it the tools to pause, reflect, and call for help when it hits a truly difficult fork in the road.
A really elegant solution. Instead of making the AI think harder all the time, you just make it think harder when it actually needs to.